Hello everybody, how are you? How are you doing? It's your teacher Murad Sultan Zvidi. So today we'll continue our lecture. Okay, second part of curved graphs. Okay, and today is 27 March 2021 and 28 March 2021. Okay, so the title is what? The title, my learners, I will make laser. So the title is Curved Graphs Part 2. Okay, we saw before how can you draw the graph of quadratic equation. Then we move also how can you draw the graph of y equal a over x, which is a hyperbola. Okay, and figure out there are its axes of symmetry and something like that. Okay, your teacher is Murad Sultan Zvidi. Your school is Samah English School, grade of course grade 10. Okay, now question, we continue. Which equation or which function corresponds to the graph at the right? Here we have a graph. Okay, at the right. Here we can use the method of completing the square to to figure out the equation of this graph. Do you think first of all your parabola is is like a valley, means opens upwards. So it opens upwards, the coefficient should be positive. The coefficient of A is positive, and this point is the minimum point. At which point exactly? At x equal 2, y equal 1. This is the turning point. The axis of symmetry is x equal 1. Okay, so it will be what? In fact it will be x minus 1 squared. Okay, plus x minus 2 squared plus 1 x. Okay, it will be x minus 2 squared plus 1. Okay, you can expand this. X minus 2 squared, it will be x squared minus 4x plus 4 plus 1. So it will be x squared minus 4x plus 5. So this is, yes, this one the correct answer. Look, when x equals 0, y equal 5. X equals 0, y equal 5. Okay, this is x. Okay, this one here, this is the 0, this is y. When x equals 0, y equal 5. Okay, when x equal 1, for example, 1 squared minus 4 multiplied by 1 will be minus 3 plus 5 will be 2. Okay, when x equal 1, x equal 2. Okay, and so on. For example, when x equal 2 squared is 4, minus 4 multiplied by 2 is 8. So 4 minus 8 is minus 4, plus 5 is 1. When x equal 2, y equal 1. So this is the turning point. So we will select small a. And now we'll move to the second one. Farah or Fatima, can you read the question? Yes, good. Which equation doesn't represent a quadratic function? So the quadratic function, my learners, has a degree 2 at the highest power. Okay, so if you see the power or the highest power or the exponent of the x terms are less, are 0 or 1 or 3 or something like that, else 2 is not a polynomial to the power 2 and is not a quadratic function. So here, look here, y equal x plus 1 plus 3 squared is a quadratic equation. You will expand this, it will be x squared plus 6x plus 9. It's a quadratic equation. And here y equal 3x squared, of course, is a quadratic equation. Here y equals 6x squared minus 1 is a quadratic equation because the exponent is 2, the highest power is 2, and also here the highest power is 2. And this one, if you are going to expand it, it will be x squared. So here there is a power, there is an exponent of 2. But this one, look here, this is is a linear equation, okay, of a straight line x to the power 1. So this one is not quadratic equation. Okay, here we have an exercises. Which graph represents a function whose corresponding quadratic equation has no solution? Okay, remember here, if you want to, let's say, distinguish between the curves or between the parabola that has real roots or has complex roots or has no roots, means that if the parabola or the curve does not cut the x-axis, so we can say that has no roots, has no solution. For example, this one, f of x, okay, is a parabola, x equal y equal x squared, or f of x equal x squared, so has two roots, double root, which is x equals 0. And here also this curve cuts the x-axis in the point -2, because this is 0, -1, -2, so it has double root, x1 equal x2 equal -1. So this has two double root, two real numbers. This one, for example, D, also cuts the curve, the parabola cuts the x-axis in two different roots, so -2 and 1. Okay, this is 1 and this is -1, -2, so the roots are -1 and -2. It has two roots. But this one, look here, this curve is in fact has a coefficient negative, and or has the x squared term is negative, and the turning point, this is 0, where is x of x, this is axis of y, and this is axis, so 1, 2, -1, 2, -1 is the vertex, so this one doesn't, the parabola does not cut the axis, the x-axis is here, so this one in fact has no solution. Okay, this one has no solution. The second question, look at the right, we have parabola. The curve seems like to be a hill or to open upwards, downwards, because the coefficient is negative, and this point is turning point, also it's called a maximum. So what are the roots of the quadratic equations whose related function is graphed at the right? Here we have a coordinate plane, and inside this coordinate plane we draw this parabola. This parabola has a vertex of 0, 3, meaning the y, this curve cuts the y-axis in 0, 3, and it has x-intercept or roots as what, as 2 and -2. So the roots of this quadratic equation in general is where or at which the curve cuts the x-axis. Clear? So this is -2, 2, or 0, 0, 4, 4. So the correct answer is the smallest one. Okay, so -2 and 2 are the two roots. Okay, then now we move to the graphs of a reciprocal function, which is called in fact hyperbola. Okay, the graphs of reciprocal function are written in the form of y equal a divided by x, where a is positive or negative. Okay, so there are discontinuous at half two parts. This is means that the curve will go closer to the y-axis but never touch it, and also for this curve of hyperbola will go so close to the x-axis but never touch it, and also here the same. This one are two curves are symmetrical by the line of equation y equal -x, and here are symmetrical by y equal x. This is also hyperbola. This is k is negative and this is k is positive. When k is positive, the curve will be drawn on the first quadrant, then the third quadrant. By what? By the axis of symmetry x, y equal -x. And here, when k is negative, and okay, so this curve now يقين. Okay, so okay, when k is negative, we told that this is k is negative, so your curve will be drawn on the second quadrant and fourth quadrant. This is second quadrant and this is fourth quadrant, and this is the line of symmetry, which is y equal x. This is when the coefficient a on the numerator is negative, and this is when the coefficient, or when a on the numerator is positive, because here y equal k over x is, in fact, the curve is called a hyperbola. Okay, so they don't cross or touch the x-axis or the y-axis, mean this curve never cross or touch it, but get near and near to them. We say that the axes are asymptote to the graph, means y equal 0 is asymptote and x equal 0 is also asymptote to the curve. Here are the general shapes of reciprocal function of the form y equal k over x. Okay, k it will be 1, 2, 3, minus 1 and something like that. If, for example, y equal negative 1 over 5, negative 1 over x, your curve will be like that, because the coefficient of k is negative. Okay, if let's say k is positive, for example 2 divided by x, it will be like that. Okay, here, for example, we have an example. Draw the graph of y equal 1 over x, where x is different, not equal to 0. Then sub question b, write down the equation of any lines of symmetry lines of the graph. Here we have 1x equal negative 4, negative 3, negative 2, negative 1, negative 1 over 2, negative 1 over 4, 1 over 4, 1 over 2, 1, 2, 3, 4. These values, the values of x. In order to find y, just substitute in this equation the reciprocal function of x equal negative 4, then negative 3, then negative 2, then negative 1, then negative 1 over 2, then negative 1 over 4, then negative 1 over 4. You will find the value of y. After that, after making this table of values, you will try to plot all these points, okay, and join the two parts with smooth curves. For example, here negative 4, 1 minus 1, negative 4, negative 4 minus 1, this one is negative 4 minus 1 over 4. Then the second one, negative 3 minus 1 over 3. The third one, negative 2 minus 1 over 2. Then we have minus 1, 1, minus 1, negative 1. Then we have minus negative 1 over 2, minus 2. Then we have minus 1 over 4, minus 4, and so on. And your curve will be like that. Okay, this is the first part that is should be drawn on the third quadrant. Okay, why? Because here L1 is positive. That's why this is in the third quadrant. To draw the symmetrical part of this, just make y equal minus x. Here this is the axis of symmetry. Okay, and let's say reflect this there, it will be like that, or just you will use a table of value. Okay, so to conclusion, here we have the y equal x, and this one y equal minus x. So this curve is reflected to the first curve that is drawn on the first quadrant is reflected by the equation or the axis of symmetry y equal negative 1 to the third quadrant, because of 1 is positive, so the curve will be in the first quadrant and the third quadrant. If the number is negative, the coefficient is negative, so it will be here and here. Clear? The equation of the lines of symmetry of the graph are y equal x and y equal minus x. Okay, for example, here you can see this part is reflected here by which line? By this one. Okay, y equal minus x, and this one is also reflected by that, by the same axis of symmetry or line of symmetry, but this part also is reflected by this. It will be here. So we have two lines of symmetry that you can use, that is useful to draw the hyperbola. Okay, now we move to the second part. we'll move to the exponential function. Is a function that can be described by an equation of the form y equal ax, where a is positive and a different to 1. Okay, so because log of 1 is 0, so we should be this one different to 1. So as with other function, you can use ordered pairs to graph an exponential function. Example number 1 here, graph an exponential function with a is greater than 1. Okay, we have a table of values for x, and we will try to find the y values. Y equal 4 to the power x. We can also write 4 is 2 to the power 2, then it will be 2 to the power 2x, so we prefer to make it as 4 to the power x in order not to let you be confused. Take the y-intercept. Y-intercept means what? When x equal 0. When x equals 0, the y equal 1. Means any exponential function should pass through this point 0, 1. Even in your sketch, without writing that the exponential function passes through the point 0, 1, you will lose 1 mark. Okay. So here x equal minus 2. Just put here x minus 2 to be 4 to the power minus 2. It will be 1 over 4 to the power 2. It will be 1 over 16. Then when x equal minus 1, 4 to the power minus 1, it will be 1 over 4. It will be 0.5. And 0, when x equals 0, it will be 4 to the power 0. It will be 1. When x equal 1, it will be 4. 2, it will be square number. Then 3, it will be a cubed number. It's very clear. Just substitute, or instead of writing x, substitute in x their values and find the value of y. Now, after doing that, we'll try to graph the ordered pairs and connect the points with a smooth curve. Okay, the y-intercept, we told, is the point at which the curve cuts the y-axis, which is 0, 1. This point. Okay, this point. Any exponential graph should pass through this point. Okay, even 4 to the power minus x, it will be symmetrical by the y-axis. X equal 0, it will be like that. Okay, and the curve here never touch the x-axis. It's go near and near, but never touch it. So we told that. Note that the y values change little for small values for x, but they increase quickly as the values of x becomes greater. For example, here when x equal 10, it will be 4 to the power 10. It will be a big number, and so on. Then just connect the points. You will get this graph of exponential function. Okay. Here we'll see this example will be in the exam. Okay, be careful to this kind of questions. The graph is a function of the form y equal ax. A is positive, greater than 1. All have the same shape as the graph in example number 1, rising faster and faster as you move from left to right. Here it will be in fact 1 over 2. It will be 2 to the power negative 1. All to the power x, it will be 2 to the power negative x. So, and 2 to the power x, its curve, it will be like that, but 2 to the power negative x should be like that. Okay, we'll do this one. First of all, we will state the y-intercept. When x equals 0, y equal 1. Okay, means that the curve should pass through this point. The curve of this exponential function should pass this point, which is 0, 1, which is called the y-intercept. Then here substitute x equal negative 3. It will be 1 over 2 to the power negative 3. It will be 1 over 2 to the power negative 3. But 1 over 2 is 2 to the power negative 1. Multiplied by negative 3 gives 2 to the power 3 gives 8. And here the same. You saw this before in the lesson of indices. And how can you, for example, write x to the power n equal 1 over x to the power negative n, and vice versa. Okay. So graph the ordered pairs and connect the points with a smooth curve. The y-intercept is 1. We told y cos simply because the curve will pass through this point. Okay, and then question number small b class. We draw this one. Now we move to small b. Use the graph to determine the approximate value of 1 over 2 to the power negative 2.5. Okay, here we reach 2, x equal 2, so 1 over 2 to the power 2, it will be 1 over 4, it will be 0.25. But when x equal, this is 0, this is 1, this is 2, this is 2.5 at the middle. We want to reach this value of y when x equal 2.5. You can use calculator, okay? And then you will make, let's say, the value of y is about 5.5. Okay, the value of y is about 5.5. Okay, and x is minus 2.5. So you just use calculator to confirm that. This here we use the curve when x equal, we told 1 over negative 2.5, negative 2.5 here, this point, I mean this point. So if you draw a line parallel to the y-axis to this point, approximately 5n.65. Now we have an exercise, my learners. Draw the graph of y equal to the power x of values of x from negative 3 to plus 3. This example we did in classroom, but I will repeat again in order to let you understand more and more. Use your graph to find an estimate for the solution of the equation to x equals 6. Okay, so when x equals 0, y equal 2 to the power 0 equal 1. Substitute x equals 0 into y 2 to the power x and work out the value. Here when x equal 1, y equal 2 to the power 1, because here 2 to the power x is 1, equal to. Repeat the process for other integer values of x. Here when x equal 2, y equal 2 to the power 2 equal 4. Means substitute x equal 2 in the equation y equal 2 to the power x and work out the value of y. Here x equal 3 and y should be equal 2 to the power x is 3 to the power 3, it will be 2 by 2 by 2, if 4 by 2 is 8. So means that between parentheses substitute x equal 2 in the equation y equal 2 to the power x and then try to figure out the value of y. When x equal minus 1, y equal 2 to the power minus 1, this is an index expression, index written, but the index is negative. You will change fraction with positive, and this will be 1 over 2 to be 0.5. When x equal minus 2 here, y equal 2 to the power minus 2, it will be 1 over 2 to the power 2, it will be 1 over 4, it will be 0.25. You use the result a minus n equal 1 over n. Did you remember when we said before x to the power n equal 1 over x to the power minus n, or x to the power minus n equal x to the power 1 over to the power x, to work out the value of the negative value of x. Okay, so here when x equal minus 3, y equal 0.25 simply because 1 over 8 is 0.25. Okay, here we have an example of exponential function. So we have x equal negative 3, y equal 0.25, x minus 2 0.25, minus 1 is 0.5, 0 is 1, 1 is 2, 2 is 4, 3 is 8. We'll draw the graph from the table of values when x equal negative 3. Negative 3, this is negative 3. Y equal approximately negative 0.125, which is 1 over 8. Then when x equal minus 2, it will be 0.5 over 4, or 0.25. When x equal minus 1, it will be a half. When x equals 0 is 1. So the curve of exponential function also passes through this point. Be careful when sketching. When x equal 1, y equal 2. When x equal 2, y equal 4. When x equal minus 2.5, it will be 3, it will be 8, and here approximately 2.3, something like that, it will be 6. Now what is the solution when x equal y equal 6? Is use the graph is 2.6. Use your graph to find the value of x when y equals 6. So thank you for listening, my learners. It's your teacher Murad Sultan Zwidi. Now it's 1 o'clock at night. Okay, thank you for listening. and I wish that the lecture will be clear and you can, let's say, answer. I can, let's say, during this lecture, at least I wish that I answered to your questions. And if you have doubt, don't hesitate to answer or ask or send by WhatsApp. And don't hesitate, I am here to help you. I am here to let you evolve your level in mathematics and to develop your skills in mathematics. It's very easy, just depend on what you have, and try to be proud of you and proud of who you are. Okay, thank you and goodbye.